Okay, in this video we're going to be going over the process for solving multi-step algebra equations, such as this one up here, okay? The 4 steps, which we're going to walk through quite a few examples. We'll also talk about how do we deal with equations like this if they have fractions in them, okay? But these 4 steps, step 1, expand and simplify. We're just going to start there. Let's not worry about the others. So what do I mean by expand and simplify? Well, anytime we see parentheses here, right, this 2 next to the 3x minus 3 in parentheses, that means this whole thing is being multiplied by 2, right? Same here, this is being multiplied by 2. So when we expand, we're going to do out that multiplication. That's what that means, okay? So the first step, remember we call that distributing. So I'll do 2 times 3x gives me 6x. And then 2 times negative 3, that's minus 6. Okay, put the equal sign, we'll do the same thing over here. 2 times x gives me 2x, and 2 times 15, right, plus 15 now becomes plus 30, and then we still have this plus 4 over here, okay? So that was expanding. After we expand, we should always check to see if there's any simplifying. And when I mean simplifying, I mean combining like terms, right? Over here, we can't simplify this anymore. These are not like terms, but notice that 30 and 4, those are both just numbers, right? Constants. So we can combine them, right? That's what we mean by simplify. So we should always check after we expand to see if we can simplify. In this case, we can. So the 6x minus 6 will remain, equals 2x plus 34. Okay. So that was step 1, right? First we expanded, and then we simplified. Sometimes you won't have to do this. So step 2 is to eliminate the x term on one side of the equal sign, okay? One side of the equal sign. Remember, this is like our dividing line. So sometimes people frame this as getting the x term just to be on one side. But the way we do that is by eliminating one of our x terms. Usually, right, where are our 2x terms? 2x and 6x. It's usually easier to eliminate the x term that has a smaller coefficient. So remember that I can add, subtract, multiply, divide by anything that I want as long as I do it to both sides of the equal sign. So what can I do to this 2x basically to make it a 0? 2x minus 2x will get me 0, right? So let's go ahead and subtract 2x. And if I do it on this side of the equal sign, I have to do it over here as well. Minus 2x. Okay, and what does that leave us with now? 6x minus 2x. Well, 6 minus 2 is 4, so 4x minus 6. And then this becomes 0. 0 plus 34 is just 34. Okay, so notice before we had x terms on both sides of the equal sign. That's a problem for us. So we eliminate one of the x terms, right? We chose to subtract 2x because I knew that would get rid of my 2x. And because I subtracted 2x, I have to do it over here as well. All right, so now this is what we're left with. 4x minus 6 equals 34. Takes us to step 3. Isolate the x term. To isolate, to get alone. So where's my x term? Again, it's 4x. What's stopping the 4x from being all by itself on this side of the equal sign? The negative 6, right? The minus 6. So how can I turn that into a 0? Right? Do the opposite. So minus 6 plus 6. And because I add 6 over here, I have to add 6 over here as well. Okay? This gets me 0. So now 4x is all by itself, right? It's been isolated. 4x equals 40. Okay? And then that will take us to our last step. Divide by the coefficient, right? The coefficient of x, okay? 4 is the coefficient of x here. So we divide by 4 on both sides. Remember, this fraction bar also represents division. 4 divided by 4 is 1x. So just x is left over. And 40 divided by 4 is 10. So x equals 10. As a reminder, What were we even doing this whole time? We were trying to figure out what number can I put here in place of x to make this equation true. And there's only one solution, and that answer is 10. Okay, so we're going to take a look at 4 more equations and go through these steps to solve them. And hopefully what you'll realize is that even if the equations are simpler, more complex, right, the process that we follow is going to stay the same. So if we get comfortable with this, we'll be in good shape. So let's go ahead and take it from here. Step 1, expand. Do we have any expanding to do, right? Parentheses are always going to tell me that I have expanding to do. But it's only on this side of the equal sign in this equation. There's just a 15 over here. So let's multiply out. 5 times x is 5x. And 5 times negative 2 is negative 10 equals 15. Okay, the second part of step 1 was to simplify, right? We should always check, but in this case, these are not like terms. There's no simplifying to be done, so we can move right to step 2. Eliminate the x term on one side of the equal sign. So we only have to do this, though, if we had an x term over here, right? If it was like plus 3x over here, then that's a problem for us, right? It's a problem when we have an x on both sides, and then we would have to get rid of it. But in this equation, because it's a little simpler, we actually don't even need to do the second step, right? We already have the x term just on one side of the equal sign. So let's skip right to number 3. Isolate the x term. Here's my x term. What's stopping it from being alone? Minus 10. So let's do the opposite. Let's make this a 0, right? And if I add 10 there, I add 10 here. So what are we left with? 5x on this side and 25 over here. Takes us to step 4. Divide by the coefficient of x. We divide by 5. We divide by 5. Just leaves us 1x, right? 5 divided by 5 is 1. And here, 5. So we found that 5 is the number that we would put here and make this equation true, right? Because 5 minus 2 is 3, and then 5 times 3 gives me 15. Okay, so here's our next equation we're going to be working with. Let's take it right from the top. Step 1, expand. So I see there's expanding to do here. I see there's expanding to do here. 5 times 2x gives me 10x. 5 times negative 3 is negative 15. And then I just copy down the plus 7, right? It doesn't disappear. Okay, on this side, 3 times x is 3x. And 3 times positive 4 is positive 12. And then similarly, copy that down, the minus 2. It doesn't go anywhere. So we just expanded. Is there any simplifying that we need to do? Do we have any like terms? Yes, here and here. So negative 15 plus 7, well, that's still going to be negative, right? 15 minus 7 is 8. This is kind of like 7 minus 15, so that would be negative 8. So 10x minus 8 equals 3x, and then plus 12 minus 2 plus 10, right? 12 minus 2 is 10. Okay, so first we expanded, and then we had to do some simplifying. That was step 1. Step 2, eliminate the x term on one side of the equal sign. Do you remember which x term I said we should choose, right? We do have x terms on both sides. We got to get rid of one. Let's choose the x term with the smaller coefficient. So 3x. This is positive 3x, so I just need to take away 3x to get rid of it. And if I do it on this side of the equal sign, I have to do it over here. Okay, what does that leave us with? 10x minus 3x is 7x minus 8. We know that this comes to 0, it cancels out, so all we're left with over here is 10. All right, that was step 2, eliminate the x term on one side. Done. Step 3, isolate the x term. I want to get 7x alone. What's stopping it? The minus 8. So we add 8 to both sides. We're just left now with 7x equals 18. And then we divide by 7. Divide by 7. We will go ahead and leave it as a fraction because it's kind of a nasty value. But we could leave it as 18/7, or I could turn it into a mixed number. Right, 7 goes into 18 two times with 4 left over, so 2 4/7. Or if I wanted to turn it into a decimal value, right, I could always just do out the division, 18 divided by 7. Okay, so here's our next equation, and we're incorporating some negative numbers, some integers into this. But like I said, the process won't change. So step 1, expand. I see parentheses being multiplied, so we need to do the expansion. We need to distribute it out. -4 times 2x. Remember, a negative times a positive is a negative, so this becomes -8x. -4 times -3. A negative times a negative is a positive, so that becomes +12, and then the +2. Okay, let's do the same thing over here. -3 times x, -3x, and -3 times +7 becomes -21 plus 2x. Okay, so we just expanded. Is there any simplifying to do? Well, over here, these are like terms, so let's combine those. -8x plus 14. And what about on the right side of the equal sign? We actually have two x terms, right? So let's combine them. -3 plus 2 gets me -1. So we have -1x, or just -x. So I'll put -1x just for clarity, but we could also write -x. Okay? -1x minus 21. So that was step 1. We expanded, and then we had some simplifying to do, right? These two and these two, combining those like terms. So now let's eliminate the x term from one side of the equal sign. We have -8x here and -1x. Let's get rid of the -1x. What do I have to do to -1x, or what do I have to do to -1 to turn it into a 0? Right? I actually need to add 1. So we're going to go ahead and add 1x plus 1x. So -8 plus 1 is -7x plus 14 equals, this is now gone, so just -21. Okay, so we eliminated x from one side of the equal sign. Let's now isolate our x term, get it all by itself. What's stopping the -7x from being alone? The plus 14. So let's subtract 14, right? Get rid of this. And if I do it here, I have to do it here. -7x equals -35. Finally, we get to our last step, divide by the coefficient of x. Divide by -7, divide by -7. X is equal to +5, right? Because a negative divided by a negative gives me a positive. Okay, we're going to look at two more equations involving fractions and discuss how do we deal with doing equations when we have fractions involved. Okay, so in this next equation, you'll notice that we have a fraction, right? 2x plus 5, the whole thing being divided by 3, or over 3. So anytime we see an equation with fractions, there's a first extra step we need to do, which is we just want to get rid of the fractions altogether. In this case, I only have one fraction, and the denominator is 3. Remember, you could think about a fraction, this is like dividing by 3. So to get rid of it, what we're going to do is the opposite of dividing by 3, which is we're going to multiply the entire equation times 3. Right? We could think about it over there, or we could think about it over here. Okay? So you can think about it like 3 over 1 for the sake of this fraction. So when I multiply the whole equation by 3, you'll notice that I then get rid of this fraction. 3 over 1 times 2x plus 5 over 3. Remember, with multiplying fractions, if we have the same number in diagonals, right, we can cancel them out. So in this case, when we multiply 3 times 2x plus 5 divided by 3, we're just left with 2x plus 5. Okay? But we also have to multiply the 3 by everything else in the equation too. So 3 times -4 would give me -12. And we even have to multiply the 3 times the other side of the equation as well. 3 times 7 is 21, okay? So there's this extra step that we have to do if we see fractions, which is to get rid of them. If I'm dividing this by 3, multiply the whole equation by 3. Now that we're here, we just follow our steps. There's no expanding, there's a little simplifying. Plus 5, positive 5 minus 12, that's negative 7. So 2x minus 7 equals 21. Let's isolate the x term, right? We don't have x terms on both sides, so we get to skip step 2. We add 7 so that the 2x is alone. And then finally, step 4, divide by the coefficient of x. Divide by 2, and we find that x is equal to 14. Okay, so this is the last equation that we're going to look at, and you'll notice that we have 3 different binomials all being divided by a different number, right? We have 3 fractions with 3 different denominators. So what we need to do is, just like if I was trying to add fractions with denominators of 4 and 6 and 3, I would need to find a common denominator. And the way we do that is by finding the least common multiple, right? Basically, if I think about my 4 times tables, 4, 8, 12, 16, I think about my 3 times tables, 3, 6, 9, 12, 15. I think about my 6 times tables, 6, 12, 18, right? These are all the multiples. We're looking for the lowest common multiple. So the lowest number that is a multiple of all 3 numbers that I see here is 12, right? So we would rewrite these with denominators of 12. We're going to use this least common multiple to help us get rid of these fractions as well, right? So when we want to get rid of these, we look at all 3. We identify the least common multiple, which is 12. Now I'm going to multiply this entire equation by 12, okay? So what that means is the 12 will be multiplied by the 2x plus 4 over 4. It'll get multiplied by the x plus 2 over 6 equals, right? It'll also get multiplied by the x plus 8 over 3. Okay, let me erase this, make a little space for us. So, right, I've just sort of distributed the 12, showing that we're going to multiply it by all parts of the equation. That's what this is showing here. Now let's go out and do the multiplication, okay? I'm going to show these as fractions, 12 over 1, because if I think about them like I'm multiplying fractions, then I can cross cancel, right? 4 and 12, those are both 4 times tables. This is 4 times 1, this is 4 times 3. Notice my denominator is now 1. I got rid of it. We can do the same thing over here. 12 and 6, those are both 6 times tables. So this becomes a 1, this becomes a 2. And here as well, 3 and 12, those are both 3 times tables. 3 times 1, 3 times 4. Okay? So now let's go write out what's left. All the denominators turned into 1s, so I don't even need to write them anymore. We have 3 times 2x plus 4, right? That's all that was left, 3 times 2x plus 4, plus 2 times x plus 6 equals 4 times x plus 8. All right, now that we've gotten rid of our denominators, we got rid of our fractions, right? Let's just go through our 4 steps. Expand. 3 times 2x is 6x. 3 times positive 4, positive 12, plus 2 times x is 2x. 2 times positive 6 plus 12 equals 4 times x is 4x. 4 times positive 8, positive 32. Simplify. Do we have any like terms? Not over here, but here we do, right? 6x plus 2x, that gives me 8x, and 12 plus 12 is 24. equals 4x plus 32. Okay? Step 2, do we have x terms on both sides? Yes, so we need to eliminate one of them. We should always choose, like I recommended, the one with the smaller coefficient. So let's get rid of 4x by doing minus 4x, minus 4x. 8x minus 4x is 4x plus 24 is equal to 32. Okay, that was step 2. Let's go to step 3. Isolate our x term. We want our x term alone. What's stopping 4x from being alone? Plus 24. So let's subtract 24, and we get that 4x equals 8. Right, we're running out of space a little bit. Let's move it over here. 4x equals 8. Our last step, step 4, divide by the coefficient of x. So we divide both sides by 4, and that gets us from 4x down to just x, which is what we were looking for. And 8 divided by 4 gives me 2. So x is 2. I hope that this video has been helpful in making you feel more comfortable tackling multi-step algebra equations. Thank you for watching, and I will catch you in the next one.